Hello everybody, we are going to continue with the topic of SoftMotion CNC using the ctrlX core. This occasion, part 3, among other things, we will see how to use external programs and how to load them from PLC. Use of M functions. Use of CNC variables. Necessary license for system activation. Sending external files to ctrlX core, etc. Control machine program from file on PC or ctrlX. To control the programs used from the control or from the PC, we will generate a new folder. To control the interpreter, we must use the next modules. Is MC read NC file 2, is MC NC interpreter, is MC check velocities. In the image we can see the generic structure with the three modules joined. The parameters with the red square are the ones that are being used for the example. The structure follows in the following order. First, the file is read with read file. The interpreter that prepares the program to be sent is executed. And finally, the speeds entered are checked. The POG data outputs generate the variable to be seen as on a program to the interpolator. On this page, we can see the configuration to activate the reading of the CNC file located on the PC. The module is activated with the same program start button used to activate the interpolator, which we will activate a bit that we will remain active until we stop the program with the stop program. The sentences output is the one that we will use it to send to the interpreter module. Acceleration, deceleration and speed values if they are not in the CNC program. In the following image, we can see the interconnection between the interpreter module and the speed check. As we have already commented in this entry, the output value of the file reading module must be placed specifically sentences. The start of the module is activated by the same bit as the reading of the file. The two indicated outputs of this module must be sent to the speed control. The PGEO infos variables contains the program data and is the variable that should be sent to the interpolator. Once the data for sending the program has been processed by the interpreter and the speed check, the reading and activation reset is carried out and a temporary interpolation activated order is activated. In the example program, and since we want to verify the functionality with the two program options, the internal CNC program and with the external programs, which will be most common, we will create these lines in the program that will allow us to make the selection. If we look closely, we will see that the two program options differ slightly. The internal program generated from SoftMotion must be treated as we have already sent by the ADR instruction. However, the program read from the PC or from ctrlX core, the definition is direct, since the speed check output instruction is in pointer to SMC outcode format. In both cases, the data that must be entered as the program file to be executed is seen in pointer mode. As can be seen, and depending on the selection generated from the screen, we can select a CNC program internal or an external one. View of the example program used. The program used from the PC or ctrlX core must have the extension *.cnc and the string type variable with the path and the name should be placed in the is file name entry of the ismc read file 2 module. In the initial example, we are using the simulation mode and also virtual access, so we can access the internal programs and also thus create on the application own PC. However, if we have a ctrlX core, we must use one of the internal paths as shown in the following image. We will see the process of sending the files to this path later. Functions. The function is an additional functionality that allows starting and controlling certain actions within the G-code interpolation. The interpolator decelerates to speed 0, sending the number of the function activated through the output and waits for confirmation within the interpolation module itself or with the use of SMC pre-acknowledge. The functions are generated from the application and are not defined by the system. Functions can send up to a total of 2 values in real format. These parameters can be displayed in the PLC program using the SMC get parameters module. The programming structure of the function is as follows. We will use plus the number of the function used. The functions also have a series of parameterizations that can be used for visualization in the PLC program. These are the data K and the L and the type O. The numbers 65,533 to 65,535 are reserved for internal functions. The maximum number of functions in the CNC program is 64. This restriction can be circumvented by inserting a G75 code before the first functions. G4 codes also count as functions. Example of operation of functions. We have generated a new folder to control these functions. Together we can use these two modules to manage the functions. SMC get parameters, used for control of functions activated with parameters. SMC pre-acknowledge function, used for the acknowledgement of a certain function m. In the CNC program we incorporate two operating lines with function m3 and m7. The first of the indicated blocks tell us that there is some function activated. However, we do not have information to know which one it is. The module also provides us with additional information assigned to the function, and that can be used in the PLC. This can be TK parameter, DL parameter, or M parameters. The interpolator module can tell us which function is activated. It is possible to acknowledge the function globally, although the use of individual acknowledgements is preferable. For the system to work, we should control the acknowledgement in a similar way to this, using the interpolator signal that tells us which function is activated. We can generate its control. This can be used to control machine states, functionalities, detectors, limit switches, etc. In the example, both functions are controlled in the same way, each with its own acknowledgement button. Standard list of functions. CNC variables. The use of variables in CNC program must be done as follows. First of all, we generate some variables to carry out the example. Next, we will use the SMC single var module to declare the variables that we will use in the CNC program. Define the variable name used in CNC program. Define variable type. Program PLC variable used. Use of uppercase names in str var name assigned is recommended. Next, we must create the variable using SMC var list that we will use to load the variables in the CNC program. If we have more than one variable, we can introduce the value of the initial array in the structure. This generated structure should be incorporated into the file reading if b. This type of variables, however, are only updated after a new start of the program. G command table, identifiers, expressions, mathematical functions. Table of commands G, extracted from the help of SoftMotion. However, some may not be included. Word type identifier list. Operator list. These expressions only work in the CNC Online program and not in the CNC program editor. Mathematical function list. Program jumps with G20. Jumps can be made in the CNC program using the G20 instruction of the G code. This type of code has two additional parameters. L parameter, target for jump. K jump conditions. These types of jumps can only be done in the online program and not with the CNC editor. Example of program in continuous mode. However, it must be taken into account that it will only be functional for 70 cycles, established by the G36 code of the N1010 line. This allows the execution line N1160 with G20 and jump to line N1020 to execute a total of 70 cycles. Examples of jumps using G20. Example in cycle determined by the internal variable assigned in G36 with a value of 10. Example number 2. In this case, the program will end when the variable is 0. Another example using the G75 command, although this case cannot be used if the program is generated as SMC outQ, which is how it is being generated from the interpreter. Jumps generated with tags. Display of G code lines. In this image, we have the way to extract the numbers of the lines of execution of the current program. However, the tests carried out have not worked correctly and the system did not show the current line number. So for the moment I have ruled out its use. Probably there is an error in the program itself, or in some of the option signs the buffer to small error always appear. The extractions of the numbers of lines, if the standard blocks do not work, can be this. we generate a string type variable with a total of 1001 objects. Obviously, it can be left at 1000 to have round numbers. This line must be added in the part of the interpreter that allows us to extract the structure of the CNC program with its corresponding lines. The comparer allows us to ensure that they will never read negative values, and in this way we will not generate a problem with the array of strings. As we can see, the lines of the program are being pasted in the string so that we already have them available in the PLC. We must add the following line in the program to be able to visualize the current line on the application screen. For the interpreter, the line that follows the initial title will always be the first of the program, although this could be of the common type. The system uses the line number for the selection of the text on the screen. With these two lines, we can show the next line to be executed. In the example, it has been assumed that there are no two lines of type common in a row in the program. If there are more lines, some modifications should be made in the program to control the existing common lines. Licenses. To be able to use the SoftMotion system in the ctrlX core, we must license these two SoftMotion options. If it is not licensed, the system can work for 1 hour in simulation mode. This is another possible error in case of not having a license. In this case, we are trying to activate a program located in the ctrlX core. Sending external files to ctrlX. Files can be sent from the PC to ctrlX in several ways. The first is from the PLC program itself. From the Files option, we can select the directory where we have the CNC program files on the one hand, and we can access the ctrlX folders. The program should be sent to the CNC folder and showing the image. Sometimes the following notice may appear since some directories do not allow file transfer. The transfer can also be carried out using, for example, the WinSCP FTP configuration used for the transfer, with that files protocol, TSL or SSL, hostname, port number, username and password. This is the path we must look for the access the CNC programs. Startup parameters for real access. For the real access, we have an option in the IO configuration that allows us to insert a series of parameters that we will modify during the startup of the ctrlX drive. By default, these are the parameters that appear in a standard configuration. If we want to add any parameter, we will use the Add button. Attention to the values to be applied and to the factors generated by the decimals. In the example, the number 36,723 is multiplied by 10,000. In this example, we are going to modify the value of parameter S00278. The data must be entered here: name, indicator only, IDN number, value type, length and value. Once OK is activated, the parameter is inserted into the startup structure. The extraction or any modification carried out in the device must be activated using the Transfer Fieldbus configuration button. For the startup to activate, we must remove power from the system and start again. For the example, we will do the following. We modify in online the value of the parameter used. After that, we must remove power from the system and start again. Once with the ctrlX connected again, the value of the parameter should have been modified automatically after the new boot. Modules for reading, writing EtherCAT parameters. The system also has within the CXA EtherCAT master library the option for reading and writing access to parameters in the EtherCAT network. Different modules are available for different protocols. In the example, we will use the SOE protocol. Example of reading the maximum speed value. The reading module should only contain the master EtherCAT masters as a pointer, the address of the EtherCAT slave number, the parameter indexer, and obviously the parameter on which the value will be read. Example of writing the maximum speed bipolar parameter. Task assignment. For the example of the application, two tasks have been used, each one with a different behavior, and also in the case of the main task depending on whether we are in simulation mode or in online mode with ctrlX core. The first option is with the access in EtherCAT and with the simulation mode disabled. If we are going to use the simulation mode, we will have to modify the data of the main task so that it can activate the modules that are executed from it. The visualization task is used in both cases cyclically, and the call time can be modified depending on the speed of execution that we want to visualize. Details of the priorities and the operation of the system task are available in the ctrlX core manual. In the following video, we can see how everything discussed in the previously viewed videos. In this case, we are working with the three real axes. First of all, we activate the power of the axis, common for all of them. First, using the program generated from the internal editor. We activate the cycle with the cycle start button, which starts the movement visible on the associated screens. In this state, and using the internal editor, we cannot know which line of the program we are executing, although we can know the number of it. At the end of the program, the end function 30 is activated. We stop the program with the cycle stop. and we select the program from the laptop or from the ctrlX core. In this case, the message will tell us that is an external program. In this case, we can already visualize the line number that is being executed, as well as the instruction that compose it, also the one that we will execute after. As you can see, the program stops when it reaches the function m3 line, waiting until we activate the reset button of this function, continuing the program from that point. Until reaching the execution line of the m7 function, waiting for it to be reset. The program will continue in this case until the end of it. The examples shown are made with the version of ctrlX Works 1.16. Special caution must be taken with the issue of the versions of ctrlX Works and SoftMotion. Thanks for your attention.